Hello everyone. In this video, we would be discussing question 3 of IBHL 2020 chemistry paper. So let's start with the question. In this question, we have been given the equation for combustion of propane. Okay, C3H8 plus 5O2 will give you 3 moles of CO2 and 4 moles of H2O. So we need to calculate the standard enthalpy change using section 11 of the data booklet. So section 11 of the data booklet contains our bond enthalpy, the amount of energy that is required to break a bond, or we can also say it's the amount of energy that would be released when a bond forms. Okay, so here in this case, which bonds are broken, if we analyze, uh, we can see that 5 double bond O bonds will be broken. All of the O double bond O bonds will be broken, because here on the product side you won't find any O bond. Okay, oxygen oxygen bond. So let's make a list here of bonds broken. So first we got is 5 moles of O double bond O, and the value from the data booklet is 498. Okay, unit is always kilojoule per mole for all of the bonds. Now we have here C3H8 looks something like this. Okay, I'm not drawing the hydrogen, but here they are the hydrogen. In the right hand side, you won't find a single CC bond. Okay, so all of the CC bonds are broken. Here we can see that there are only 2 CC bonds. Okay, the 2 CC bonds have been broken. The value of this bond enthalpy is 346. And we also can't find any CH bonds on the product side. So all of the CH bonds are also broken. How many CH bonds were there in the reactant side? 1, 2, 3, 4, 5, 6, 7, 8. So 8 CH bonds have also been broken. The value is again 414. Okay, so summation energy of all bonds broken would be 5 times 498 plus 2 times 346 plus 8 times 400. It's 414. Upon adding them, what we get is 6494 kilojoules. Okay, the unit would be kilojoule. Now bonds formed. Okay, we need to find out which of the bonds have been formed. So here I have CO2. Okay, so let me just remove this and let's analyze. So there had been no, I mean, in the reactant side there are no C double bond O's. Okay, so total of 6 C double bond O bonds have been formed. Okay, I can say that 6 moles, because there are 3 moles of CO2, so each mole contains 2 C double bonds, a total of 6. Okay, so I can say 6 moles of C double bond O has been formed. Bond enthalpy here is 804. And for H2O, if I analyze for H2O, what we see here is interesting, that there are 2 OH bonds that are formed per mole. So total of 4 moles are present. So 8 moles of OH bonds are produced too. And the value here is 463. Unit is always kilojoule per mole. The summation of bonds formed would be 6 times 804 plus 8 times 463. This comes out to be as 8528 kilojoules. Now delta H is defined as summation of bonds broken minus summation of bonds formed. So it would be 6494 minus 8528. The final answer here comes out to be as minus 2034 kilojoules. This is the answer to this question. Now in the next question, we need to again find the enthalpy change using section 12. Section 12 actually contains the enthalpy of formation of compounds. I'll write the values which are necessary for this thing. HF value for H2O is minus 241.8. HF for CO2 is minus 393.5. HF for C3H8 is minus 105, and we know that HF for O2 is 0 because it's in the same elemental form. You can assume it as 0. So delta H is basically summation of HF products minus summation of HF reactants. Okay, so products is we have 3 moles of CO2, so 3 times minus 393.5 plus we have 4 moles of H2O, so 4 times minus 241.8 minus in the reactant side what we have is this we have 1 C3H8 because O2 is 0, so minus of minus 105. So finally here we get the delta H as 2 minus 2043 kilojoule, and this is the final answer to this question. Now here in this question we have been given the equation of combustion for propane. We need to find out if the entropy change is negative or positive. To check this, it's very easy. Check the number of gaseous moles in reactant side. On the reactant side, has you can see there are 5 moles of O2 and 1 mole of this propane. Okay, so 6 moles of gas, while product side has, you can see 3 moles of CO2 and 3 moles of CO2 and 4 moles of H2, so 7 moles of gas. So as the number of gaseous products is increasing, so our delta S or the entropy change is positive. Delta S is positive. Now in this question, we need to calculate the delta S for this reaction in joule per Kelvin. So the entropy of formations is given in your section 12. So for H2O, this is 188.8. CO2 is 213.8, or propane it is 270, and our SF for O2 is basically 205. So again, delta S would be summation of SF products minus summation of SF reactants. So it's 4 times 188.8 plus 3 times 213.8 minus 1 time 270 minus 5 times 205. So yeah, that's it. So upon calculations we get that this delta S comes out to be as 102 joule Kelvin inverse. Okay, and all the units that all the units here, they are also in joule Kelvin inverse. Now coming to the last question, here we need to calculate the delta G. So we know that delta G is basically delta H minus T delta S. Delta H has already been calculated in part B as minus 2043 kilojoule, and delta S in part T has been calculated as how much, 102 joule Kelvin inverse. We would convert delta S to kilojoule because that will help us. Okay, so it's done. So delta G now is basically delta S, that is minus 2043, minus we need to convert this temperature to kelvins, and that makes it, so upon simplifying this thing, what we get here is minus 2071 kilojoule. This is delta G, and this is the final answer to this question. And with this we end this video, and the other questions of IBHL 2022 will be live on this channel within a day or so. Okay, thank you so much, and don't forget to like this video and subscribe to our YouTube channel.